Alright, welcome a Chaks solution. This is vector 2, intersection of two lines here. So we can find the intersection of two lines in 3 dimensions. Right, so we have steps that I've outlined here so that we can follow those steps when you're solving the intersection of two lines. Right, so the first step here, express the equation in column notation and you equate them. Then the second step is to solve for the parameters. For example, you can solve for lambda and mu by using either of the two parametric equations. Then number 3, you check for consistency using the parameters. Then you also write the final step here is to write the point of intersection if the equations are consistent. Alright, so now let's go to the questions here. Alright, so the first question that we have is show that line M and N intersect and state the coordinates of our point of intersection. So this is our line M and this is our line N here. Alright, so the first thing is to write this a vector equation in column form here and you equate them. So the first one here you can see it's minus 5 minus lambda. So minus 5 a plus times minus 1 is minus 5 minus lambda here. Then minus 1 times plus 1 lambda, so it's minus 1 plus lambda. Then 12 a plus lambda times minus 1 is 12 minus lambda here. So this is the first vector equation here, equals to the other part here, which is another equation here. So you combine the two parts here to become one component here. Alright, so now we have this line 1, line M equated to line N here. So the next step is to solve for the parameters here by either solving two of the equations. So you can see here we have the first equation, second equation, and third equation here. So in this case, we are going to take the first equation and second equation and solve for lambda and mu. Alright, so we are solving simultaneously here. Alright, so now we are adding these two equations to eliminate lambda here. So if we add them, we are going to have minus 6 is equals to minus 3 plus 3 mu here. Alright, then it becomes minus 3 is equals to 3 mu. Then we have mu is equals to minus 1. So that's the value of what? Of mu. So now we can also solve for what? For lambda. So we are going to substitute mu into equation 2 here. So this is going to be minus 1 plus lambda is equals to minus 3 plus minus 1 here into equation 2 here. So you can see lambda is equals to minus 3 minus 1 plus 1 here. So lambda is equals to what? Is equals to 3. So we now have the values of mu and lambda here. So we now want to test for consistency whether these parameters will also satisfy the third equation here. So we just substitute the value of lambda on the left hand side and the value of mu on the right hand side here into this part here. So you can now see the left hand side we have minus 2 equals to minus 2 here, then minus 4 is equals to minus 4. Then on the last part here you can see 15 also equals to 15. So it means the left hand side is equals to right hand side. So it means these equations are consistent, so they intersect. Alright, so what is now our point of intersection? So they are intersecting at this point. So you just go and write these coordinates. These points minus 2, minus 4, 15. That will be your point of what? Of intersection here. Remember the question is saying show that they intersect. So if we want to show that they intersect, we test for consistency. Then the coordinates of point of intersection, these are the point of intersection here. So it's minus 2, minus 4, 15 here. So we write these coordinates as point of intersection. Alright. Alright, so let's go to the next example here. This is our next example. Given that the line L1 and L2 are perpendicular and they intersect. So this is our line 1 and line 2. And they say they are perpendicular and they intersect. So the questions are as follows. Find the value of M. Then find the value of N. Then item 3, state the coordinate of intersection. All right, so we are going to start with the first part here. So we know that for perpendicular lines, the dot product of the direction is equals to 0. So we are going to do the dot product of the direction. So our direction here is this one, which is minus 264 dot. Another direction is m2 minus 1 here. Then you do the dot product here. So it's minus 2 times m plus 6 times 2 plus 4 times minus 1 here, which is minus 2m plus 12 minus 4 is equals to 0. So you can solve for m here. So m is equals to 4 here. That's the value of m here. All right, so now if you look closely, they are saying these lines, they intersect. So if they intersect, it means the equations are consistent. So we are just going to equate these two lines and solve for the value of t and and s here. All right, so finding the value of n, since the line intersect, so we equate the line. So we have the first equation, second equation, and third equation. So the first equation is expressed in column form, and the second equation is also expressed in column form. Then we equate them here. So now we take the first equation and the second equation and solve for t and and s here. All right, so now let's see the first equation and the second equation here. So now we are solving for t and s. All right, so we can simplify the first equation by taking 4 to the other side, so it becomes 11 minus 2t is equals to 4s. Then the second equation here, we can take 10 to the other side here, we can have minus 5t plus 6t is equals to 2s here. So we need to solve for t and s. So in this case, I can use the elimination method. That's why we have this 2 which is multiplying here, so that we can have 2s 4s here. So we multiply this second equation with 2, so we're going to have 11 minus 2t plus 4s. Then the second equation becomes minus 10 plus 12t is equals to 4s. So now we can eliminate here by subtracting equation 1, by subtracting the equation. So we can subtract from equation 1 to equation 2, or 2 to 1 here. So by subtracting, we are going to have 21 minus 14t is equals to 0. So t is equals to 3 over 2 here. So now we can also solve for s. So substituting t into equation 1 here. All right, so you can see we have 8 is equals to 4s. So 4s equals to 8 here. So s is equals to 2. All right, so now these are the values of t and and s. So the next thing, now we know that these lines are intersecting. So which means these equations are consistent. So which means if I substitute the value of t in place of t here, and I also substitute the value of s on the other side here where we have s, the left hand side of this part also equals to the right hand side here. So you can see here 4 is equals to 4, so the x part is consistent. Then 14 is also equals to 14, so you can see the y component is also consistent. So since they're intersecting, so this part again minus 4 will be also consistent to the other part of z here. So minus 4 is equals to n minus minus 2 here. So n minus 2 is equals to minus 4, so you can solve for n. So n is equals to minus 2. So that's the value of of n. All right, so now item 3 there now says state the coordinates of intersection. So the coordinates of intersection is very simple. We are just going to return to this part here. So you can take 14 minus 4 as your point of of intersection. That's your point of intersection. All right, so let's go to the next example here. So they are saying show that the line L1 and L2 do not intersect. So these are the lines that we have. So we need to test for consistency here, right? So now we're just going to equate these two lines here. So in column form, this is the first line. In column form, 1 plus 2t minus 2 plus 2t here, then minus 5 plus t is equals to the second line, 3 plus 4s plus then 3 plus s here, then 0 minus s here. Alright, so now we can take two of the equations here, then we solve them simultaneously to solve for t and s, then we test for what? For consistency, right? So we are taking 1 and 2 here, and we are solving simultaneously. So now we have the first equation and second equation. So by subtracting equations here to eliminate t, we can see that we are going to have 3 is equals to 3s here, then s is equals to 1. Alright, so now we can substitute s in either equation 2 or equation 1 here. So we are substituting s in equation 2. So we have minus 2 plus 2t is equals to 3 plus s, so s is 1 here. So you can see 2t is equals to 6, so t is equals to 3. So now we want to test for consistency. So to test for consistency, we are going to substitute t equals to 3 and s equals to 1 into this equated vector equations here that we have. Alright, in column form, so we go and equate. So t, we are going to place it on the place of t here, then s we also place in place of what? Of s. So we are going to say that we have 7 is equals to 7, so the x coordinate are consistent, then 4 is equals to 4, the y coordinate are consistent. Then this one, you see that minus 2 is equals to minus 1, so which is inconsistent here on the z coordinate here. So which means these two lines do not intersect, since the left hand side is not equals to the right hand side. So the equations are inconsistent, so they do not intersect. Thank you for watching the video. See you in the next lesson.